This example is just like an AP free response question, and it's non-calculator. You can see it says we're given that the velocity of the particle of a particle is given by the function v of t. So this is the velocity function here. It's equal to 3t plus 6. And we're also given an initial condition. So we've got the position at t is equal to 2 is 3. So that's going to be important later on. Now, we're definitely going to use the knowledge that we gained in this unit, or even in this lesson 7.7 here, to help us to solve the problems in this example. But keep in mind that you're going to need to use the knowledge that you've gained all year to help you through some of these. So let's take a look at part A. It says, is the particle moving to the left or the right at t is equal to 2? Justify your answer. What we want to do here is we want to look at the value of the velocity when t is equal to 2. If the velocity is positive when t is 2, then the particle will be moving to the right. If the velocity is negative when t is equal to 2, then the particle will be moving to the left. So with this first one, we're given the velocity function. We don't need to find the derivative or even find the antiderivative. We just want to evaluate that velocity when t is 2, and that'll give us the sign of the velocity, which is what we need here for this one. So that'll be 6 plus 6, or 12. We don't know what the units are, nor are we asked to give them, so we won't be able to do that. But it does say justify our answer, and our answer is not 12 for this one. The question is the particle moving to the left or the right? So we're going to say the particle is moving to the right when t is equal to 2. And we want to justify our response, so we'll say because v of 2 is greater than 0, or you can say v of 2 is positive. We'll move on to the next part here. So here we're asked about the position of the particle. What is the position of the particle for any time t is greater than 0? And we're actually given a function notation for this. If you're not given function notation here, you can go ahead and define your own. But here we've got s of t. So to find s of t, we're actually going to want to find the integral of, or the antiderivative of, the velocity function. So we'll write that like this. We'll say s of t is equal to the integral of v of t. Just to remind myself what that is, it's 3t plus 6. And we need our differential here, dt. So if we work with this one here, we've got the antiderivative of 3t, which is 3t squared over 2, and then plus 6t. Also remembering there could be a constant hanging out there that we're not sure of, but actually we can go ahead and find the particular solution here. We just found the general solution by using this information here. The position of the particle is 3 when t is equal to 2. So s of t is 3 when t is 2. So we'll just do a little substitution here, and this hopefully will allow us to find that value of c. So we'll have 3 is equal to, now this will be 3 times 4, which is 12 divided by 2, so that's 6, plus 12 plus c. So we'll subtract 18 from each side, and we'll wind up with c being negative 15 for this one. So we'll go right from this line where we first introduced that c, or found the antiderivative, and we'll write s of t is equal to 3t squared. That's supposed to be a t right there. Divided by 2 plus 6t. And then we'll do minus 15. That's that c value that we found here. So it looks like we've answered that question. We found the particular solution. We were using all our given information here to figure out what that is. Looking at part C, it says, does the particle ever change directions? Justify your response. So to check to see whether the particle changes directions, we need to see whether the velocity changes signs. So let's go back to that velocity changing signs here. And of course, we've got a restriction for t is greater than or equal to 0 here. So what's going to happen when t is any positive number to the velocity? We're looking at this guy right now. And so you can see here that when t is positive, 3 times a positive number plus 6 is always a positive number. So we're not going to have any change in signs of the velocity. Therefore, the particle is not going to be changing directions over or for t is greater than or equal to 0. So we're going to say that here. We're going to say for t is greater than or equal to 0, the particle does not change direction or change directions. We want to justify a response, so we'll write because v of t is only positive. Then we could say over, or for all t, oh boy, t is greater than or equal to 0. Try to erase that here. Over t is greater than or equal to 0. And that would be about it. For D, it says find the total distance traveled by the particle for t is equal to 1 to t is equal to 4. So when we're looking at total distance here, we need to see if there's any change in direction. We already did that in part C. We said there isn't. So the total distance for this particular particle is going to be the absolute value of s at 4 minus s at 1, or the difference between the positions. And of course, we want to use the absolute value there because distance is only going to be positive. Total distance, that is. So we'll look at what s at 4 is first. So we'll go back to our equation over here for s of t, which is 3t squared over 2. Might have to go back and forth a little bit here. So that's going to be, let's just write that down here. So we've got 3t squared over 2. And then we're going to have, let's see here, I'll have to reference it just one more time, I think, 6t minus 15. Perfect. So we've got plus 6t minus 15. So what we're going to do is we're going to figure out what that is for s at 4 and s at 1. So we'll try that on the right-hand side of the board here. So we'll have 3 times 4 squared divided by 2, which is going to be 3 times 8, or 24. Or you could do 3 times 16, which is 48, divided by 2 is also 24. Then we'll have 6 times 4, which happens to be 24, and then minus 15. So s at 4 will be whatever 48 minus 15 is, so that should be 23. Or 33, how about that? Ugh. Bad mathematics there, huh? 48 minus 15, 30. Well, actually, that should be and actually that does happen to be 33. I had to take a quick pause there. Freudian slip or a brain fart, huh? Hope that you're okay with that little mistake there, but it actually is it is 33. So we'll go with s at 4 as being 33 for that one. And we'll have to figure out what s at 1 is then. So that'll be 3 times 1 squared over 2, which is just 3 over 2, plus 6. 6 times 1 is 6, minus 15. So we'll have 3 over 2 minus 9, and 9 is also 18 over 2. We'll want to put these fractions together. So 3 minus 15 is negative 15 over 2. So we'll put that right here. Now we got to keep that minus sign right where it needs to be. And then s at 1 is negative 15 over 2. And it's the absolute value, of course, of all of that. So 33 minus negative 15 over 2 is the same as 33 plus 15 over 2, which happens to be 81 over 2, or you could write this as 40 and a half as your final answer. So either one of those will be fine.